Welcome to the Professional Data Engineer Crash Exam course. Today we will focus on Cloud SQL, a fully managed relational database service on Google Cloud. Cloud SQL supports MySQL, PostgreSQL, and SQL Server, making it a versatile choice for various workloads. It's ideal for structured data and for lifting and shifting legacy SQL RDBMS. The operational boundary defines responsibilities. The user manages schema, queries, and compute sizing, while Google manages infrastructure, OS, database patching, backups, and high availability. Cloud SQL offers substantial machine scale with up to 64 terabytes of storage, 60,000 IOPS, 96 compute cores, and 624 gigabytes of RAM. Storage supports vertical autoscaling, and automatic encryption is enabled by default. Solid-state drive, or SSD, is the default and high-performance choice for Cloud SQL storage. Billing is based on uptime, CPU allocation, memory, storage volume, network egress, and licensing for SQL Server. Cloud SQL is record-based, optimized for high-throughput writes and OLTP workloads. BigQuery is column-based, optimized for high-throughput reads, aggregations, and OLAP workloads. Federated query bridges both. Cloud SQL is strictly record-based. The constraint is that the entire record must be opened on disk, even when selecting only a single column, which is an important consideration for I/O performance. Read replicas are exact, read-only copies of the primary instance, updating in near real-time. They offload work from the primary and share the read load across multiple endpoints in the same region. Cascading replication allows creating a read replica under another replica, bridging regions. This improves performance by offloading replication work and reduces networking costs for cross-region replication, dramatically expanding read capacity. Recovery point objective, or RPO, is the acceptable data loss threshold, and recovery time objective, or RTO, is the acceptable downtime threshold. Automated backups with point-in-time recovery via write-ahead log archiving are key to redundancy. The topology of resilience uses a cascading hierarchy for disaster recovery. In an outage, a selected read replica is promoted to primary, maintaining the 99.95% availability SLA. Secure networking boundaries are critical. Core connectivity integrates seamlessly with App Engine, GKE, GCE, and Cloud Run. The private IP rule requires a private services access connection. The Cloud SQL Auth proxy establishes secure connections via a secure tunnel, encapsulating and forwarding database traffic, authenticated via Google IAM. A best practice is to enforce exclusive use of the auth proxy for maximum security. Data ingress uses Storage Transfer Service, or STS, or Transfer Appliance for bulk loads, and GSUtil for on-premise files. Data is staged in cloud storage, with format constraints requiring SQL dump or CSV files and compression. The database migration lifecycle involves 4 steps: define the job, create an initial read replica, continuously synchronize data, and finally, promote the read replica to the primary instance to finalize the cutover. Cloud SQL Insights provides a 7-day retention window to detect and diagnose query performance problems. Stackdriver monitoring requires a MySQL connector to stream telemetry for continuous monitoring, helping maintain the 99.95% SLA.